Hi, welcome to the video tutorial for the Thinking Math lesson called Accuracy and Error. For a while this was my favourite lesson and I never finished it, and I think that illustrates the ownership that you can have over these lessons to expose children to thinking, that mathematical thinking, scientific thinking that underpins the world. And I know this lesson always tickles the pupils, and I think it's good to give them a chance to articulate their ideas. So again, it's focusing on oracy, it's focusing on reflection, it's focusing on metacognition. There is a long way you can go in this lesson. There are 3 parts to the lesson, and really most of the time I only ever do 2 parts, because I focus on the children explaining their ideas. What I would like you to do is to read the lesson plan, because there's a lot of rich maths in this activity, and decide which questions you're going to ask when, and decide on what maths you want your pupils to focus on, knowing your classes. It could just be the enjoyment, it could be the engagement. I know some schools where they've used these materials, they've put children in tutor, where they've blocked timetable, then they've put children in tutor groups for doing these lessons. I've walked into schools to teach these lessons, and a child said to me, "Oh, it must be a thinking maths lesson because we always do this in thinking maths lessons." And it's lovely. They do remember it. And I've got memories of children whose mums have spoke to my wife in the hairdresser and said the only lesson that Charlie loved was those lessons that you did. So there is something really interesting about engaging pupils in mathematical thinking and the joy of mathematical thinking. This lesson means a lot to me because it's linked to sport, and I like athletics, and this lesson always made me think about when I was 18, I was in a pub and I watched Steve Cram break the world mile record, 3:46.32, and I used to start talking about that to the children. But really, when you've got sports such as the Winter Olympics, the Paralympics, cycling, maybe cycling is not a good example with the state of the Sky team, but there are lots of sports you can use, motor racing, any sport that involves very high degrees of accurate timing. And so I would play some video clips. A few years ago, I used to play the clip of Kelly Holmes winning the gold medal in the 800 metres, beating Maria Mutola, and almost being pipped by another athlete coming up on the side. And you show some close finish. And you say to them, "How much did she win by?" "That much, that much." "Well, how much was that in seconds? How much did she actually win by?" You could then say, do you time sports day in the same way, or it doesn't need to be as accurate? So why is accuracy important? So you have a bit of play around with it at the start. Pick some example of some sporting scenario where it's really close, just to get them thinking. I've had people where they ask people to clap 10 times to clap a second apart. Do anything to get them to think about the time and accuracy and subdivision of time. And so the lesson starts, the first worksheet starts, where you ask pupils to do a simple sum that's come from adding up two person's time on the ski slope, such as 2.7 and 1.9. The answer is 4.6. And you say, okay. And a lot of this lesson is based upon the children using and applying their mathematical understanding, and it often takes a while in this lesson. So you say, okay, this skier got 4.6 seconds. On my watch, another skier got exactly the same time, but the judges were still able to tell them apart. How could they do that? And that's the first period of discussion. So the children are challenged to unround the number and realise that 4.6 seconds, there's a range of what 4.6 seconds could be. It could be, some will say 4.69, but then say, no, it can't be that, it's got to be 4.65. Others will then say, well, it can go back to 4.55. So there is a range of what 4.6 seconds could be. And I think it's because of the context. They're taken by surprise, and it often will take them ages to realise you can unround numbers. Often we just ask them to round numbers, but actually here we're asking them to unround numbers so we could tell people apart. You don't say there's a more accurate clock, you just say, oh, the judge's clock was able to tell them apart. So that's quite interesting how long that can take. The first episode comes to the end where you show them a number line, and you might have 4 and 5 here. And you say to them, how many numbers can you think of between any two markers on the number line? And I've often got pupils to go into pairs, to go into fours, to explain infinity. That you can always have markers between the markers. And I've had real lovely examples of pupils explaining how that's possible. There's always space between the numbers for a number. And I think it's something about getting them to do it on a number line makes them think about decimals. It's really, really fascinating. But it's a lovely time for them to think about ideas about how many numbers can you fit between any two markers on the number line. Some think there's got to be 9, because normally we have 9 markers. And someone said, what about between those two? What about between those two? And it's a lovely period for children to reflect upon the infinite. It happens in a couple of the lessons in the shape strand that the videos you'll see soon. But it's a very, very lovely activity for children to explain infinity, and I think it really does tickle children in year 7, year 8 to explain this. The second part of the lesson focuses on absolute and relative error. And I think this is important because there are a lot of health scares. There was one to do with the contraceptive pill a few years ago where the relative error was given and not the absolute error. And because they gave the relative error, there were lots of unwanted pregnancies because people stopped taking the contraception. And because of that, there were a lot of unnecessary terminations, unwanted terminations because people got pregnant because they didn't understand the risk. And I think it was something like, your risk of getting cancer doubles. Now, that is going to scare anybody. What they didn't tell you was the absolute risk had gone from 1 in 160,000 to 1 in 80,000. If you give it that way, it changes the actual risk. But it's this misunderstanding of the meaning of relative error rather than absolute. And so this lesson focuses on a scenario where 2 people go to the shop. Someone goes to buy a bike that costs £129.95, but is charged £129.99, and someone goes to buy a chocolate bar for 15 pence and is charged 9 pence. What's the same? What's different? Does it matter? And I think children then imbibe this lesson with their own understanding, their own meaning, their own purpose. There are other activities you can do where you have to measure a desk and measure it to the nearest centimetre, round it up, round it down. But this is a lovely part of the lesson where they have to, they've often not done it before. They'll say, but it's 4 pence. It's 4 pence. 4 pence is 4 pence. But you say, well, actually, 4 pence relative to 15 pence is quite a lot. No, it's not. It's 4 pence. It's not compared to that, but it's still 4 pence. So it's giving the pupils that opportunity to argue and discuss the difference between 4 pence as an absolute error and 4 pence as a relative error is really interesting. Because then you can start talking about examples of car parks where they don't give change. And it might only be 10 pence, but actually, if there's 100 people use a car park, that's a lot of money in a day. That's a lot of money over a year. You could talk about a company adding half a pence onto everybody's bill. Not much, but actually over millions of consumers. You know, so I think there's lots of interesting real-life mathematical links in this lesson. And the third part, which is a part sadly often don't get onto, is where you start looking at the size of the error based on the rounding. So you give the children a different scenario of the population on a country is 5,784,346. A car costs 4,775 pence. A path is 3,123 metres long. What I want you to do is I want you to round that and work out the error. Then round it in another way and work out the error. And talk about, is the error important when we round? Where might it be important? Where might it not be important? You could talk about marathons where they've they've got the distance wrong, and it's not been an official marathon because it's too short. But it's about 26 miles. So I think there's lots of interesting maths here. You get them to round it once, look at the error, round it a different way. And is the size of the error that important? When might the error be important? It's like where my daughter bought some flowers for Mother's Day for her mum the other day, and we know the florist, and she gave her £20, and the flowers cost £17, and she said, oh, here's a £5, I haven't got any change. That's a similar issue of how important is that error. It's very important to her because she gets £2 back because she doesn't have much money. So I think there's a manifold, many ways that you can use this to explore issues, and also to link it to some of the things the older pupils are going to be asked.